Section 8.4 is slope of a line. I can find and interpret slopes of lines. The slope of a line is the ratio of the line's vertical change, called the rise, to its horizontal change, called the run. In example 1, a wakeboard ramp has a rise of 6 feet and a run of 10 feet. We're going to find its slope. So here, the ratio of rise to run, we can write as a fraction. Rise to run. Again, when we talked about proportions before, we had 3 different ways we could write them. We could write them in words, we could write them as fractions, or we could write them with a colon. And this is the way that we're going to use, rise over run. So here our rise is 6, and our run is 10. We're going to reduce here where we can. 6 divided by 10, I can take a 2 out of each of them, and my slope is going to be 3 over 5. And this, our slope, is going to be our rate of change. To find the slope of a line on a coordinate plane, we can find the ratio of the vertical change between 2 points on the line and the horizontal change between the 2 points. So m is what we use for slope, and that's our rise over our run. And our rise, okay, our vertical change is our change in y coordinates. Rise, y's, kind of sound the same. Run is our change in our x coordinates, our left to right. So to find our change, we find the difference of them. We subtract. So we're going to take the y value from one point minus the y value from another point over the x value from our first point minus the x value of our second point. So we're going to find our difference in our y's first and our difference in our x's in the same order as far as our points go, and then reduce if possible. We can use the diagram on page 405 to compare the slopes of different lines. Imagine you're walking to the right. We read graphs left to right, just like we do books, left to right. So if the line rises, okay, so if it starts low, goes higher, the slope is positive. If it falls, if to the left it's high and as we go to the right it goes down, negative. Negative slope looks like the slant on an N. So if we make an N, it slants down. Horizontal line has a slope of 0. Okay, it doesn't go up at all, so there's no rise. And a vertical slope is undefined because our run is 0, and we can't take a number divided by 0. We can take 0 divided by a number, and that's okay, but we can't take a number divided by 0. We call that undefined, and that happens whenever we have a vertical line. In example 2, we're going to find the slopes of the lines shown on page 405. So in part A, they have a line here and they've picked out 2 points for us. We're going to use the points 1, 2, and 4, 5. So in the book, in the picture, we can count our rise over our run if we want to, but we're going to focus on using our formula. So remember, our formula is going to be one of our y values minus our other y value. And whichever y we use first, we have to use the x value from that same point minus the x value from the other point. And that's going to give us m for our slope. It doesn't matter which point we use first as long as we're consistent. So I'm going to use the 5 first minus my other y value. And since I used 5 first, I have got to use 4 first. So it doesn't matter which point we start with as long as we start from the same x value as we did y. Here I get 3 over 3, which reduces to 1 over 1, which is just 1. So here, my slope equals 1. In B, the 2 points they gave us, 0, 1, and 3, negative 3. And they have a picture of what that graph looks like on page 405. Here, the framework, okay, for my formula is that I'm going to subtract on the top divided by subtract on the bottom. I'm going to put negative 3 first, and since I use negative 3 first, I have to use 3 first for my x's. The same ordered pair goes in the same column, on the same side. Now, my y goes with my y, my x goes with my x. In my numerator, I get negative 4, in my denominator, I get 3. So my slope is negative 4/3. Something to consider here, guys, is if we go with the opposite order on our points, let's say I would have done 2 minus 5 and 1 minus 4, both of these would have been negative, which still would have gotten me to a positive 1. Same thing here. If I'd have done them in the other order, I'd have had a positive 4 over a negative 3, which equals the same thing, negative 4/3. So it doesn't matter which order we do them in as long as we're consistent. So whichever y value we start with, we have to start with the x value from that same point. Feel free to pause here and give these a try if you'd like. Find the slope of the line through the given points. Again, our formula is our change in y's, rise, over our change in x's, our run. So y's and rise go together. My framework, I'm going to put my y value first and my x value first from the same point. My y's both go on top, so 7 minus 2. My x's both go on the bottom, 4 minus 1. So this should be an ordered pair, and this should be an ordered pair. 7 minus 2 is 5, 4 minus 1 is 3. And we leave this as 5/3. We don't take it to a mixed number. We always leave it as an improper fraction in simplest form. Same idea here on number 2. Again, it doesn't matter which point we use first. So here I'm going to use the 5 first. Minus 1. And since I used the 5 first, I've got to use the negative 2 first. Negative 2 minus my second x value, 6. I get 4 over negative 8. Simplify where we can. So I'm going to take a 4 out of each of these, and I'm going to have negative 1 over 2. Again, my slope, my change in y's, y2 minus y1, over x2 minus x1. Doesn't matter which point we use as long as we use the same point in the same order. So here I'm going to set up my framework, subtract in my numerator, subtract in my denominator, subtract in my numerator, subtract in my denominator. I'm going to use this point first, so 0 minus negative 9. Remember, when we subtract a negative, we actually get a positive. Minus a negative gives me a positive. Since I use 0 first for my y's, I use 0 first for my x's, minus 3. This is going to give me a positive 9 over a negative 3, and when I reduce there, my slope is going to be negative 3. Here I'm going to use 0 minus 8. Since I use 0 first, I have to use 5 first, minus 7. I should have 5, 0, and 7, 8 as my ordered pairs. Here I do. My numerator, negative 8, and my denominator, negative 2. Reduce if we can, and here I get 4 for my slope. Again, if we'd have done these in the other order, if I'd have done 8 minus 0 and 7 minus 5, I would have had a positive 8 divided by a positive 2 and still gotten to 4. So the order doesn't matter as long as we keep it consistent. In example 3, we're finding the slope of the line shown on page 406. So on 406, in part A, they have a line, horizontal line, and the points here are 1, 3, and 4, 3. Again, my slope formula, y2 minus y1 over x2 minus x1. So our change in y's, our rise, over our run, our change in x's. So my y's, 3 minus 3 over, since I used this 3 first, I'm going to use this 1 first, 1 minus 4. I'm going to get 0 divided by negative 3, and 0 divided by any number is okay. We just get 0. So here I have a 0 slope. And that happens anytime that we have a horizontal line. In B, the 2 points that they give us for our vertical line here are 2, 3, and 2, negative 1. Set up my framework and plug in my values. 3 minus negative 1, remember I'm going to add there, 2 minus 2. I get 4 divided by 0, and a number divided by 0 never works. We call this undefined. Okay, we can never divide by 0. And that happens every single time that we have a vertical line. Feel free to pause here and give this a try if you'd like. Find the slope of the line through the given points. Tell whether the slope is positive, negative, 0, or undefined. So we can check whether it's positive, negative, 0, or undefined by doing like a quick sketch. So 2, 3 is about here, and 4, 5 is here. So it looks like this is going to be positive. So let's check that by finding our slope. Again, we set up our framework. I take y minus y over x. Since I used 5 first, I have to use 4 first over 2. 2 over 2 gives me a positive 1. So my slope here is 1, and it is positive. If you want to show that just by doing a little picture like that, you sure can as well. Here, I have 6, 3, and 6, negative 1. It looks like it's going to be a vertical line. And we know that vertical lines are undefined, but let's check it. Set up my framework. 3 minus negative 1. 6 minus 6 gives me 4 over 0, which again, we know can't be done and undefined. So again, if you wanted to do that as a line, you sure could. In 7, negative 7, 4, 5, 4. Looks like it's going to be a horizontal line, which means my slope is probably going to be 0, but let's double check it. 4 minus 4, negative 7 minus 5. 0 over negative 12 does give me 0. So my slope is 0. We were right. And in 8, I have 1, 5, and 4, 1. So here it looks like it's going to be negative, but let's find our slope and check. 5 minus 1. Since I used 5 first, I've got to use 1 first. 1 minus 4. 4 over negative 3. So my slope, I'm going to take that negative just right up front, negative 4/3. So we were right there. In example 4, they have a graph of a wakeboarder's the distance traveled. So the graph on page 406 shows the distance traveled by a wakeboarder as a function of time. The slope of the line gives a wakeboarder's speed, which is the rate of change in distance traveled with respect to time. So rate of change is the same thing as slope of a line. We're going to find the wakeboarder's speed here. So they picked out 2 points for us. They gave us 2, 52, and 7, 182. So here it'd be a lot harder to count our rise and our run, so we definitely have to use our formula here. y2 minus y1 over x2 minus x1. I'm going to set up my framework and plug in my values. If I use my bigger y first, guys, it just usually means we're going to have less negatives. It doesn't mean that we'll always get rid of them, but we will have less of them. So if I use the 182 first and then the 52, and since I use the 182 first, I have to use the 7 first minus 2. When I subtract here, I get 130 feet in 5 seconds, because this is dealing in feet and this is dealing in time, which if I divide gives me 26 feet per second. And that is our wakeboarder's speed or rate of change or slope, which all happen to be the same thing here. And that's all I have for section 8.4.